Hi there, this is a continuation of our lecture on hypothesis testing, and especially now we're talking about hypothesis testing when n is large. The sample size or the value of n, the population, is large. So when do we basically move away from a binomial distribution to a normal distribution? Is when the value of n becomes very large. So x has, let's say, a binomial distribution. Now, if x has a binomial distribution, what we are saying is that x is binomially distributed with mean n, and the proportion is p. If we were to move away from this to a normal distribution, this is what's going to happen. When n is large, say for instance n greater or equal to 30, then we're going to have to approximate to a normal distribution. Having said that, okay, the normal distribution will have a mean and a variance as well. So how do we calculate the mean? I'm sure you've learned this in previous lesson. So the mean, which is E of x, and that's mu, is calculated by taking n times the proportion, so np, and also if you want to find the variance of x, it's going to be equal to npq. And of course, the standard deviation is the square root of that, all right? So, having said that as well, now we have a parameter like this. X is normally distributed with mean np and variance npq. Right. So, of course, now you need to also bring into perspective your test statistic. So the test statistic, the test standardized, I would say, let's say standardized, okay, test statistic, which is z, is equal to x minus the mean, the observed mean, the observed mean minus the mean mu, np, over the standard deviation, and the standard deviation is the square root of the variance npq. Okay, and now this is now the test statistic z, which is normally distributed. 0, 1 would be the standardized test. Surely, because you know that your distribution curve is going to look something like this. Okay, and now from here, there's something very important that we need to bring into perspective. But before we do that, if I were to calculate the probability of x is equal to r, so that's going to be equal to the probability of x minus np, all of that divided by the square root of a variance, npq. And we further know that x is equal to r, so we have r minus np divided by the square root of npq. And this is what we have. And earlier on I was telling you that something very important here. You're moving from a binomial distribution to a normal distribution. So when we do that, we need to take into consideration the continuity correction. The reason for this is because this is a normal curve. It's a continuous random variable. We're moving from a discrete random variable to a continuous random variable. Therefore, we need to apply the continuity correction. So after continuity correction, we're going to have something like this. Probability of x is equal to r is going to equal to probability of r, I mean here x minus, all right, so right, so we have to say then probability of x, which is then r minus np minus 0.5, okay, plus or minus 0.5 over the probability of x, okay, over the square root of the standard deviation npq, okay, and this is less than z being less than r minus np plus 0.5 over the square root of the standard variance npq. Of course, I've put the plus 0.5 here and the minus is here because this one is greater than this. All right, so yeah, so this is how you go about and calculate your probability after applying the continuity correction. If you were to move away from a binomial distribution to a normal distribution, so these are the steps, various steps that you need to go through. And of course, I'm not just talking about moving away from a binomial distribution to a normal distribution, but we're talking about that with respect to hypothesis testing. So how are we going to carry out the hypothesis testing? And when we have a situation like this, in my next video, I'm going to make sure that I take a question and work out the question in full detail and see how we're going to put all of these together, especially the hypothesis testing when it comes to all this here, moving away from a binomial distribution to a normal distribution. And I thank you for your attention. Take care.